Hello, and welcome to this presentation, Getting Started with the CMA180 ACP Measurements. In this presentation, we'll explain how to configure and use the Rohde Schwarz CMA180 radio test set to measure channel power, occupied bandwidth, and adjacent channel power. This presentation assumes a basic understanding of channel power, occupied bandwidth, and adjacent channel leakage ratio. If you're unfamiliar with any of these topics, or if you'd like a brief review, you might want to watch the presentation Understanding Channel Power, Understanding Occupied Bandwidth, and/or Understanding Spectrum Analyzers ACLR before beginning this presentation. The CMA180 Adjacent Channel Power, or ACP function, measures the power of a designated radio channel and its adjacent channels. This measurement provides information on how much of the designated channel power leaks into adjacent channels, a situation that is undesirable, but is also somewhat unavoidable. The measurement produces three different types of results. The first two are a measurement of the occupied bandwidth of the radio channel, as well as the absolute power of the radio channel. The third is the absolute and relative powers of the adjacent channels, that is, the two channels above and the two channels below the designated radio channel. ACP measurements are started by going to the global toolbar and then selecting either the TX or Expert scenario under the Analog or Digital tabs. The ACP configuration and results are then accessed via the ACP tab. The device under test can be connected to either the RF COM or the RF in connectors on the front of the CMA. This is selected in the RF Settings tab. Note that these two connectors have different maximum input power levels, 100 watts continuous and up to 150 watts maximum on RF COM, but only plus 20 dBm or 100 milliwatts on RF in. An external attenuation value, either from an attenuator or due to cable loss, can also be specified. Note that this RF connection is the only one required for ACP measurements, although other types of connections can also be made. For example, an audio connection to supply an AF signal to the DUT audio input. Now let's look at the main ACP analyzer screen. The buttons on the right side are used to start, stop, and pause the measurements. At the top of the screen are the most important measurement parameters. In the center are the channel power bar graphs, and at the bottom are the numerical values. In the remainder of this presentation, we'll go through each of these areas and explain how they're used in performing adjacent channel power measurements on the CMA180. Let's start by going through the most important measurement parameters. Frequency should be set to the center frequency of the designated radio channel, and the expected power should be configured slightly higher than the maximum expected input signal power. This is the same as the reference level in many spectrum analyzer applications. The channel spacing and the channel bandwidth can be configured directly on the main GUI, but these values can also be accessed via the configuration icon on the right-hand side of the display. The bar graph result shows 5 bars, with the designated channel in the center. Note that this bar graph is normalized to the power in the designated channel, so the central bar will always have a height of 0 dB. Below this are the numerical values. For the designated channel, both the current, minimum, and maximum power, as well as the occupied bandwidth, are displayed. The two bars above and below the designated channel are the first and second adjacent channels. For each of these channels, the current power is given in absolute values of dBm, and the current value for ACLR is given in units of dB, that is, as power relative to the designated channel. Standard deviation values are also provided for each of the adjacent channels. Statistical values are accessed and enabled using the configuration icon on the right. Checkboxes are used to select either the average or max values. Note that only one checkbox can be enabled at a time. The number of values used to compute statistics is defined by the statistics count value, which can be entered by pressing the RF Stat button at the top of the screen. The configuration icon in the right bottom corner of the main screen provides access to various settings, some of which are not available from the main GUI. These are separated into 3 tabs: Measurement Control, RF Settings, and Limits. Let's take a closer look at some of these parameters, starting with Measurement Control. Most of the parameters under Measurement Control are available elsewhere in the GUI, but there are a few additional parameters here that are worth noting. First, the measurement repetition can be set to continuous or single shot, and these repetition parameters can be coupled to other measurement tabs. ACP length, which gives the number of samples used in computing the signal's FFT, is also shown here, but note that this is a purely informational value and cannot be edited. Next to channel spacing and measurement bandwidth is the offset parameter, which can be used to move the center of the designated channel either up or down by 1/2 channel. This is useful when making measurements of single sideband modulated signals. And lastly, the occupied bandwidth percentage specifies the percentage of signal power that defines this bandwidth. The default value is the industry standard value of 99%. Next, we'll look at RF settings. Here again, most of these settings are available from other locations within the GUI. One important parameter that is not found elsewhere is standard, which only appears when making measurements in digital mode. A predefined standard such as DMR, P25, etc. can be selected, or a custom standard can be defined. If a standard is selected, bandwidth and channel spacing will be automatically set according to that standard. Note too that some standards, such as NXDN, may have additional parameters as well. The Limits tab allows power limits to be configured for the designated radio channel, as well as for the adjacent channels. The upper and lower channel power limits must, however, be symmetrical, but they can be individually enabled or disabled. An upper limit for occupied bandwidth can also be configured. If the measured values violate any of these configured limits, that value will be displayed in red. For example, here our signal has an occupied bandwidth that exceeded the user-defined value of 20 kHz. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set can make measurements of channel power and occupied bandwidth, and can also simultaneously measure the amount of power that leaks from the designated channel into the adjacent channels. This latter measurement is called adjacent channel power, or ACP. The bandwidth of the channels and their spacing is user-definable. This can be done manually by the user, but can also be configured from a predefined standard for many common digital modulation types. The results of these measurements are shown as a bar graph, as well as in numeric format. In addition to current values, statistical results, such as average and max values, are provided, and limits can be used to visually indicate values which exceed user-defined thresholds. This concludes our presentation, getting started with the CMA180 ACP measurements. If you'd like to learn more about adjacent channel power, the CMA180, or other CMA180 measurements, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.